Today we are covering chemical shift. Let's get right into it.
All right, so comparing the carbonyl region between hydrogen and carbon NMR. That's the biggest difference. That's what we're going to talk about first. So I'm going to go to carbon first, and I'm going to draw an arrow to the carbonyl carbon. The reason for that is when we're looking at the carbon NMR, we're looking for the electron density on the carbon, not the hydrogen anymore. And that's obvious, but it's something you really need to think about. So I'm going to draw these electrons for you. And we're going to have two buzzwords. They're going to be resonance and electronics. These effects are going to be very important throughout the semester, especially now, because we're going to use those two ideas to tell us which one of these will be the most shielded and which one will be the least shielded. The way we are going to go about that is resonance should be most familiar to you. So we're going to do that first. Resonance is the movement of electrons. So the electrons are going to move between the two oxygens. Electronics are a little bit harder to understand, but they're not too bad. So electronic effects are basically saying that this CH3 is able to lightly donate some electron density to that carbon. Same thing here. So between the aldehyde, and I'm going to number these 1, 2, and 3. Between 1 and 3, we have 1 carbon donating group or 2 carbon donating groups. Between these two, the most shielded one is going to be the one with 2 donating groups, right? So we can already tell that 3 is more shielded than 1. But now let's talk about number 2. There are 2 oxygens, so you would think that that is pulling the electron density even harder, so that must be the least shielded. But you would actually be wrong, and that is because if you think about it, the electron density is going like this. It's going back and forth right here. Statistically speaking, that means it's going to spend more time and at any given moment be more likely to be at this carbon because the electrons are flowing back and forth. So a lot of people are surprised, but this is the most shielded in this region. It's going to be approximately 180 ppm. Next, we already discussed between 1 and 3. 3 is going to be more shielded because it has 2 donating groups, and it's donating by electronic effects, and it's going to be approximately 190. And last but certainly not least, we have the aldehyde. The aldehyde is going to be the most de-shielded, so it's going to be the highest number. It is 220 ppm. When we move on to the hydrogen NMR, though, the rule is a little bit different. So let me go ahead and draw ketone. And we're focusing on that hydrogen, right? We have the same exact idea going on here, except now instead of the carbon, we're looking at the hydrogen. Again, you're probably thinking, duh, Rosemary, you just said that. But now when we look at this resonance effect, same thing is going on. It's exactly the same molecule, but instead of pulling the electrons towards what we're looking at, which was the carbon, now we're looking at the hydrogen, and it's pulling the electrons further away from this hydrogen. So the trend is actually flipped around. Now, excuse me, for this hydrogen, it is going to be the most de-shielded. So this is going to be your 12 ppm. Now, between the aldehyde and the ketone, The aldehyde is going to be your 9 ppm. And the ketone is actually not even going to be in this region. So I'm going to go ahead and cross that sucker out. It is actually in the alkyl region. And the reason is, in order to be in the alkyl region, the hydrogen must be attached to a carbon that is only attached to other carbons and hydrogens. If you look here, this hydrogen is only attached to a carbon that is attached to carbons and hydrogens. Ha. That's about it for the actual regions. So write them down, understand these concepts, and memorize the NMR. Here for the NMR, rank them in order of decreasing chemical shift. So we're actually using hydrogen and sorry. And the trick is to remember the differences that we just talked about between carbon and hydrogen. Since we literally did it 1 second ago, I'm not going to re-explain what I just said.